Alright, tonight starts our first of 3 videos that are going to involve the concept of sum and difference formulas. We're going to start tonight with sine and cosine. So if you think about a sum formula, that refers to addition. So the sine of an angle plus another angle, and cosine of an angle plus another angle. Our difference formulas will refer to those with subtraction, using our words from operations within mathematics. These formulas are on your identity sheet, so you might want to have that next to you as we're going through and doing these problems. You will have it with you for all of your tests and quizzes, so that should help as well. The sum and difference formulas allow us to find the trig values of angles that are on the unit circle. I mean, all angles are on the unit circle, but ones that aren't are special triangles, the 30, 60, 90 angles and the 45, 45, 90 angles. We're going to be finding things like the sine of 75 degrees or the cosine of 15 degrees. So ones that fall in the middle of or some combination of the angles that we already have information for. Something really important, the sine of 75 degrees is equal to the sine of 30 degrees plus 45 degrees. It is not equal to the sine of 30 plus the sine of 45. We have special formulas that we're going to use. Those formulas are derived from a really lengthy proof involving the law of cosines, which is something we'll learn in Unit 6, and the distance formula. And that's how we get our formula for cosine of alpha minus beta, so the difference formula for cosine. Then from that we can get the addition formula, or the sum formula for cosine. And the sum and difference formulas for sine follow from the fact that cosine and sine are co-functions, and their identities are related to one another. But we are not going to bore you tonight with all of the proofs. We are just going to expect that you can use them and recognize them to condense them down. So you're going to be asked to do 2 different things tonight. First, you're going to be asked to do this side of it, where you want to recognize sine, cosine, cosine, sine as something dealing with the sum of a sine formula. Sine, cosine, cosine, sine, again, something dealing with sine. These ones down here, cosine, cosine, sine, sine, cosine, cosine, sine, sine, deal with cosine, either the sum or the difference. Easiest way to remember it is that sine says its name first, cosine says its name first. My teacher used to have a little chant, sine, cosine, cosine, sine, cosine, cosine, sine, sine. It also helps to remember that you're taking the sine of A, cosine of B, and since you're doing a sine first, then a cosine, this addition stays addition. Again, we have a different sign, sine and cosine, okay, stays a different sign. Whereas these ones down here, we're starting with addition, and we've got both of our cosines near each other, so that addition changes to subtraction. Here we've got subtraction, we've got both of our cosines together, and it changes to addition. Okay, so just kind of think about those patterns. Again, we do not expect you to memorize the formulas, but the more familiar you become with them, the better off you'll be. So that's the first way, is to recognize them and condense them down into these expressions. The other thing is to start with one of these expressions and expand it out to find an exact value for the sine of some angle plus another angle. Okay? So we're going to start with taking the right side and simplifying down to the left. First thing you want to think about, this says sine, cosine, cosine, sine. So I know it's going to be one of the sine formulas because it starts with sine. Because it starts with sine, it's going to keep that same sine in the middle. This angle is 165, so that's going to become my angle A. This angle is 45, that's going to become my angle B. So really this is asking me to find the sine of 120 degrees. Since that is a known value on my unit circle, I can say my final answer is the square root of 3 over 2. Alright, next one. This one says cosine, cosine, sine, sine. So starts with cosine, I know it's going to be some form of cosine. Because it starts with cosine, it's going to have the opposite sign on the inside. My first angle A is 20 degrees. My second angle B is 40 degrees. So overall I'm looking for the cosine of 60. And since that's on my unit circle, my final answer is going to be 1/2. So again, this whole expression can be simplified to just this. This time we're going to talk in radians. Again, we're worried about the formulas first. So cosine, cosine, sine, sine. Starts with cosine. It's going to have the opposite sign in the middle. I'm going to say my first angle is pi over 12. My second angle is 5 pi over 12. When I add those two things together, do a little bit of fraction work, I get 6 pi over 12, which is really just pi over 2. So I'm looking for the cosine of pi over 2. That is something that is on my unit circle. So my final answer is just going to be 0. This next one, sine, cosine, cosine, sine, starts with sine. So the sign in the middle is going to stay the same. 4 pi over 9 and pi over 8. Do some fraction work to add those two things together. Find some common denominators. Over 72. 41 pi over 72. That most definitely is not going to simplify to something on my unit circle. So I can't find an exact value like I did on the previous examples. This is as far as I can go, so I'm going to stop there. Alright, because your final angle inside your sine or cosine was not one that was on the unit circle. Okay, so now we're going to think about starting with the left-hand side of our equations and expanding them out to the right-hand side to find exact values. This is again one of those types of problems that there's a lot of ways you can start them, and it's really up to your personal preference if you like to add or if you like to subtract, and what angles you use to get there. So our goal here is to pick two angles on the unit circle that add or subtract to 105 degrees. We have a lot of options. We could say 60 plus 45. We could say 135 minus 30. We could say 330 minus 225. And there are quite a few others. I'm going to say you can pick any two angles that are going to get you to 105 degrees. So for this example, I'm going to choose to do the 135 minus 30. So using my formula, this is cosine with subtraction. So I'm going to write cosine, cosine, plus, because this is going to switch operations, sine, sine. Now, because 135 and 30 are on my unit circle, the cosine of 135 is negative root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 135, square root of 2 over 2. Sine of 30, 1/2. This is going to be negative root 6 over 4 plus root 2 over 4. I can't combine the negative root 6 and the root 2 because they're different radicals, but I can combine these fractions because they have a common denominator. So negative root 6 plus root 2 all over 4 is the exact value of the cosine of 105 degrees. If you type in cosine of 105 in your calculator, and then you type in negative root 6 plus root 2 over 4, you should get matching decimals because they are matching ratios of the sides of a triangle. Now, just so you trust me, hopefully you already do trust me, but if not, I'm going to show you that we could have talked about the cosine of 60 plus 45, in which case we would take the cosine of 60 times the cosine of 45 minus, because the sign will change, the sine of 60 times the sine of 45. Cosine of 60 is going to give me 1/2 times root 2 over 2 minus the sine of 60 is square root of 3 over 2 times the square root of 2 over 2. All of this is going to simplify to the square root of 2 over 4 minus root 6 over 4, which is exactly the same thing that I got over here. So it does not matter as long as you're picking two angles on the unit circle and accurately putting them together using your formulas. This might look a little different in the middle, but your final answer should come out the same. Alright, so now thinking with radians gets a little bit trickier because you don't necessarily recognize 19 pi over 12 as something that two radian measures add to. But this denominator of 12 could be reached in a few ways. It could be reached with a 3 and a 4 in the bottom, or it could be reached with a 4 and a 6 in the bottom. So you want to think about things that will get you to a common denominator of 12, and then your numerator would need to be 19. So go ahead and think about that for a second. See if you can come up with one version of something over 3 plus something over 4, and one version of something over 4 plus something over 6 that's going to get you to 19 pi over 12. Go ahead and pause your video. Alright, two examples I came up with would be 4 pi over 3 plus pi over 4. Because when you find a common denominator here, you're going to get 16 pi over 12 plus 3 pi over 12, which gives you 19 pi over 12. The other one you could do is 3 pi over 4, which when you find common denominators, you're going to get 9 pi over 12, plus 5 pi over 6 is going to be 10 pi over 12. When you add them together, you get 19 pi over 12. So I'm going to choose to split 19 pi over 12 into this one here, 3 pi over 4 plus 5 pi over 6. Using my formulas, I'm going to say this is going to be sine of angle A, cosine of angle B, plus cosine of angle A, sine of angle B. So that's sine, cosine, cosine, sine. Applying what I know for my unit circle, this is going to be root 2 over 2 times negative root 3 over 2 plus negative root 2 over 2 times 1/2. It's going to be negative root 6 over 4 minus root 2 over 4. I can't combine the radicals, but I can combine the denominators. So negative root 6 minus root 2 all over 4. You will start to realize that a lot of your answers look like this, with various addition and subtraction, or positives and negatives with your root 6s and your root 2s. That's because we're going to be oftentimes combining things on our unit circle, and when we use our formulas, you get similar answers every time because of your reference triangles. So your strategy: find two angles on the circle that add or subtract to the given angle. Plug the values into the sum and difference formulas with the angles. Then go through and use your information from your unit circle, multiply things, and simplify your answer as far as it allows. Also remember that we have those examples where you take the expanded version and you condense it back down just by recognizing the formula. This last one I want you to try on your own, and I'm going to have you first try to see if you can come up with the angles that could get you to negative 7 pi over 12. So again, think about that denominator and think about getting to a negative angle. There's a lot of ways to get there. Think about them, come up with a few if you want to, and then see if your answers match mine. So go ahead and pause your video and see if you can figure out this one on your own. Pause now. Alright, so I came up over on this side, close out of there. Over on this side I listed out a few different options in a color, and then I showed you how they converted with the similar fractions or common denominators to get negative 7 pi over 12. There's other ones too that you may have picked. I chose to go with this one, pi over 4 minus 5 pi over 6, so that's what got put inside of my cosine. Applied my formula, simplified, got negative root 6 plus root 2 over 4. If you think about it, that was our answer when we did the problem cosine of 105 degrees. If you wanted to, you could convert this to degrees, and you would find that it would also be 105, except it would be negative 105. But we know the cosine of a negative is equal to the cosine of the positive because the fact that cosine is an even function. So if you don't like converting to radians and trying to figure out your fractions, you can go back to degrees. But again, I don't recommend it. Try using your similar or your common denominators, thinking about things over 4 over 3 or over 4 and over 6. Keep your formula sheet next to you. Make sure you're not overlooking any steps, and always pick two angles that are on the unit circle that add or subtract to the angle that you are being asked about.